far?
Not bad. The chapter 5 is not so difficult, but just still a little bit like confusing about how to find mole, how to find gram or something a little bit.
Oh, the mole and the mass. Okay, the
Yeah,
gram.
the mole, the mass, like still confused myself. Maybe I read a little bit more. Maybe okay.
Yeah. Okay. Do you want me to go through it quickly here?
Yeah, and everybody here or no? No one here.
No, 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 not usually. I don't know. Like sometimes I have one student or two students, or sometimes no one show up.
Mm-hmm.
Yeah.
Because normally last on Monday I go to the what Joseph group, the review section group,
Oh, the
and
review section.
then
Yeah, yeah.
yeah, so many students in there. That's why we a little bit learn a little bit over there.
Yeah, yeah, that is fine with me. That is fine. What I'm doing, like every time no students show up, I just practice, give you some
Mm-hmm.
practice example. I try to do it here, record it, and post it in Canvas. That's what I'm doing.
Okay.
So you are
Mm-hmm.
fine. Yeah. Uh-huh. So let me go through the email. Sorry, through the mole and mass quickly. Look at here.
Yeah,
Uh, mole means two things. You have to put this in your mind. Okay. Uh, so just one
I
second.
don't saw anything.
Okay. Do you see the whiteboard?
Yeah, I see whiteboard now. Yeah.
Okay, 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 sounds good. So mole mean two things. One mole, X.
Mm-hmm.
X could be anything. Will give
Okay.
you number. So this is the first
Mm-hmm.
meaning. Mole mean number. Which number? It is Avogadro's number, 6.02 times 10 to power 23 of X.
Atom is
Atom could be molecule,
yeah
could
Adam,
be
right?
any, yeah, could be atom, could be molecule, could be ion, could be electron, could be anything, any object. One mole. Let's say, for example, one mole of phone will give you 6.02 times 10 to power 23 phone. One mole of oxygen atom will give you 6.02 times 10 to power 23 of oxygen atom. One mole of
But
water.
it's gonna be Adam, right? It's because I still confused about the gram to Adam.
Okay, look at
Yeah,
here.
gram to Adam and
First of all,
gram
first of
to mole.
okay, I will talk about this meaning in 1 minute. Give me 1 minute. I'm talking
Okay.
about the first meaning of mole. Mole
Mm-hmm.
mean number. When it
Okay.
means one mole of anything give you 6.02 times 10 to power 23 of that things. It doesn't matter what it is. Atom, molecule, ion, whatever it is. Okay?
Mm-hmm.
The second meaning of mole mean mass. One mole of X will equal mass of X in gram unit. Now, what is how you will get the mass of X? If it's atom, you will get the atomic weight. If it's molecule, so it will be the molecular
Mm-hmm.
weight. So let's say, for example, I have 1 mole of carbon. Now, what is the mass of the carbon? Carbon is atom, so you will use the atomic weight. What is the atomic weight of carbon? Do you remember it from the periodic table?
12.
Yes, that's correct. So 1 mole of carbon will equal 12, but in a gram unit, you will put a gram. So 1 mole of carbon equal 12 gram. Now, 1 mole of oxygen equal what?
16.
16 what? 16 gram.
16 gram.
That's correct. Now, 1 mole of water, H2O, here will equal the molecular weight. How you will find the molecular weight? It is the summation of the atomic weight of all the elements in the molecular formula. So here I have H2O, 2 times 1 for the hydrogen, plus
Mm-hmm.
1 times 16 for oxygen, give me 18. So here the molecular weight will be 18 gram.
Mm-hmm.
Okay, now let's say 1 mole of carbon dioxide, CO2, how many grams?
It's 1 multiply 12 plus 16 multiply 2.
What the total? It is 44. 44 grams. Okay?
Yeah.
So mole mean numbers and mole mean mass. If mole mean mass, you have to look what you have. If it's atom, you will use the atomic weight. If it's a molecule, compound, you will use the molecular weight.
Okay.
You get it right now? Before starting with summer practice, you get it?
Yeah.
Okay. Now, you have to keep in your mind the meaning of mass. This one mole of X equal mass of X. This one, we call it molar mass. Molar
mass.
Molar mass.
Wait, Professor. Okay, Professor, sorry.
No, it's okay. So the molar, are you ready right now?
Yeah, I write it down. That's why.
So 1 mole of X equals mass of X, and that represents the molar mass. Okay?
Mass. Okay.
Now, you have to keep in your mind also these factor, these two meaning, we will use it as a conversion factor. And this conversion factor, we can write it down as a numerator and denominator. So here, I can say 1 mole X divided by 6.02 times 10 to power 23 of X. Or you can flip it also, because we will deal with it as a conversion factor. I can say 6.02 times 10 to power 23 of X divided by 1 mole X. Same things with the molar mass, with the second meaning. Here, say 1 mole of X divided by mass of X in a gram. Or you can flip it and say mass of X in a gram divided by 1 mole X. Okay?
Yeah.
So look at it. When you are dealing with the question, talking about mass or mole, you have to use one of these factors, or sometimes we need to use both factors in our calculation. So look at here. Let's remove this and practice here. I will keep these two factors right now in front of you so you can see it. These two meanings, sorry. Okay. And let's look at this equation. How many mole in 3-2 gram, let's say CH4 methane? How many mole in 32 gram CH4? Now, look at here. You need to know which factor you will use. What do you have here? A gram. It is a mass.
A gram.
What they are asking here?
Mole.
Mole. So you have to go back and look which one has a relationship between mole and mass.
The 1 mole X over mass X gram.
That's correct. It means the meaning number 2. So here, start with the given information. 32 gram CH4 times that conversion factor, the meaning 2. Now, it's very important, you know, how you will write it down. Which one will go to the top, which one will go to the bottom, to the denominator. Always keep in your mind what we learn in the dimensional analysis. Given times the factor. How you will write down the factor? The given in the bottom to cancel it, and the wanted, what they are asking, you will put it in the top.
Okay.
So that factor number 2, how you will write it down? which one will go to the top, the mole or the mass?
The mole.
The mole. So you will put 1 mole CH4. I know our mass is CH4.
Yeah.
What about the mass? You will put in the bottom.
It's 12 plus 4 is 16.
8 grams. You will put it in the bottom. Okay.
Mm-hmm.
Kilogram CH4 with a gram CH4. Do the math. 32 divided by 16, it will give you 2 mole CH4. You get it?
Mm-hmm. Yeah.
Now, let's keep going and practice with another example. Let's say here, how many CH4 molecule and 3.2 mole CH4.
Okay, we're going.
So look at here. What do we have here? 3.2 mole.
Mole.
What they are asking?
Molecule.
Molecule. So which factor you will use?
Molecule.
Number 1 or number 2?
Yeah, this one that I confusing. Molecule.
So look at here. What they are asking, how many molecules? That means they are asking about number.
Mm-hmm.
Okay. So here, this X could be atom, could be molecule. So here, they are asking for number. They give you mole, they are asking for number. So which factor has a relationship between mole and number? Is it number 1, meaning, or number 2?
Number 1.
Number 1, okay, because we have 1 mole X, give us number. This is the number, Avogadro's number, we call it 6.02 times 10 to the power 23. Okay, now start with the given information, 3.2 mole CH4 times the factor. How you will write down the factor? Which one will go to the top? Which one will go to the bottom? Is it the mole go to the top or the number?
The number on the top.
The number on the top. So it will be 6.02 times 10 to the power 23 CH4 molecule. Okay? And in the bottom, we will put 1 mole CH4. Now cancel mole CH4 with the mole CH4. Do the math. Here we will get approximately 1.7 approximately times 10 to the power 24. Just check the number after me if you want.
Okay.
I'm not sure about it. Okay, CH4 molecule. And this is the answer. Okay?
Yeah.
Okay, now let's practice with another example. Okay, let's say how many a gram, or sometimes they ask you what is the mass. What is the mass? N. Let's say, for example, we have 1.2 times 10 to the power 20 H2O molecule. So we have 1.2 times 10 to the power 20 water H2O molecule. What is the mass for this one? Now, you need to know which factor you will use. Look at here. What do you have here? 1.2 times 10 to the power 20 H2O molecule. What does represent? Is it mass or mole or number?
Mole.
Is it mole?
Number.
Be careful. This is molecule. The mole, they told you it is a mole. So there is a
Okay.
difference to be careful. Okay,
Okay.
so it is number. Now,
Number. Okay.
what they are asking
They're asking mass.
for math. Now, which factor you will use? Number one or two or both?
Number. The
Which
mass
factor?
is the gram.
That's
But
correct. The mass is gram. So which factor has a relationship between number and mass? Do we have one or two has a relationship between mass and number?
yeah, we have one more x over 6.02,
Yeah, but
10
this is
power 13,
okay.
and
But
one
this is
mass.
mole and number. This is mole and number. I'm asking, is one or two has a relationship between number and mass? One
Yeah,
or two?
yeah, they have relationship the mass x gram over 1 mole.
Okay.
So we can use both, right?
So when you have this situation, number and mass, you will use both of them.
Okay.
Okay. Now start with the information. 1.2 times 10 to power 20 H2O molecule times the first factor. Use any, start with any factor.
Mhm.
Be careful. You need to know how you will write it down. So here,
The
I will.
first factor is
Which one will go to the top?
the 6.02 multiplied by 10 power 23rd of H. 1 mole.
Which one will go to the top?
1 mole on the top.
One more. H2O on the top. And the bottom, 6.02 times 10 to power 23
Oh.
H2O. Now, times the second factor. How you will write it down?
Mass X in gram.
Okay, what is that?
Mass in gram.
Yeah, but can you tell me what is the mass of the water in a gram?
No, it's gonna be, oh yeah, it's mass. Mass is 18,
18.
right?
18 gram.
18 gram H2O over 1 mole.
H2O. Now, cancel H2O molecule with the H2O molecule, mole H2O with the mole H2O. Now do the math, and you will get here the number of grams. So you will get gram of H2O. You can try to do the math later, but that's what you will do. You will multiply this number, 18, and divide it by this number, and you will get here the mass in a gram for the water.
Gram. Okay.
You get
Moment.
it?
Yeah, you get it. Professor, moment, I write it down.
Okay. So this is the type of a question that we will have it for the mole or the mass or the number. Okay.
Yeah.
You have to know which factor you will use. Sometimes we need to use one factor. Sometimes we need to use both of them. And also you need to know how you will write it down. Which one you will put it at the top in numerator. Which you will put it at the bottom in denominator. And after that, you will just do your math. Okay?
Okay.
This is very important. Go ahead.
Okay, yeah. Wait, I'm still write down. So.
Oh, yeah, just write down. It's fine. And I will post this video also in the campus, just in case if you need to review it again.
Okay. Okay, Professor. And another one is like they give us the molecule and then they asking atom. That like they give you like the H2O and then they asking about the H2 only H. So
what do you mean they are asking for the mole or what?
I saw on homework, I forget it.
Can you check this one?
Moment, please.
Okay, take your time.
What? I...
Are you talking about when, for example, they ask how many mole of hydrogen in?
Yeah, in like hydrogen in water or in something
Okay.
else. That
Okay. Now, look at here. I think I get what you are asking, but let me just talk about it quickly and see if it's the same what you are asking or not. Look at here. Let's say, for example, we have 1 mole H2O, okay? And
yeah,
here they are asking how many mole of hydrogen, how many
yeah,
mole of oxygen in this amount of water.
yeah,
So how you will deal with this type? Look at here. We have mole-to-mole ratio between atom and the molecule, or the molecule with another molecule in a chemical equation. Here, we will find the mole-to-mole ratio between the atom and the molecule. So look at here. Here, how many hydrogen you have in the water?
2.
2. So 2 times the mole of that molecule of, here we have the water, which is 1, will give you how many mole of hydrogen. So here I have 2 mole hydrogen. Oxygen, how many oxygen I have? 1
1.
times 1 mole water, okay?
Mm.
Give me 1 mole oxygen also. Okay, let's say, for example, I have 0.2 mole Na2SO4. Give me how many mole of sodium, how many mole of oxygen, how many mole of sulfur here. What you gonna
What?
do?
Is a 2 sodium.
2 sodium, 2 mole?
Yeah, 2 mole sodium.
No. Look at here. How many sodium we have? 2 sodium, that's correct. But how many mole we have for the compound? It is 0.2.
0.2.
So it will give you 0.4 mole for the sodium.
Mm.
Okay? For the
Yeah.
oxygen, we will do the same things. How many oxygen we have?
For 1?
Is it 1? Look at here.
Oh, 4.
4. So it will be
Yeah.
4 times.
Multiplied by 0.2.
Give you 0.8
8.
mole oxygen. Now for the sulfur, how many sulfur we have?
1.
1 times the 0.2 give you 0.2 mole for the sulfur. Okay?
Yeah.
That's how you will deal with it. Let's say, for example, I have 0.5 mole Na3PO4. give me how many mole of sodium here. What is gonna be?
How many sodium? It's gonna be 0.5 multiplied by 3.
That's correct. So it will be 3 times the 0.5, and we will have 1.5 mole sodium. Okay?
Yeah.
So that's how you will deal with it. Okay? You will look how many atoms or we have in the chemical formula. Then you will multiply it by how many mole of that compound we have. So let's say, for example, we have this equation. Look at here. Is that what you are asking about it or something different?
Yeah.
Okay.
Yeah, this one.
Okay, sounds good.
Because this one I also cannot get it.
Okay, look at here. Let's say, for example, how many mole of hydrogen, okay, in let's say here 9 gram H2O, for example, like this. How many mole of hydrogen we have in 9 gram H2O? Now look at here. Here they are asking for mole and the gram. So first of all, we will use the second meaning of the mole as a conversion factor. So it will be 9 gram H2O times, excuse me, times the molar mass of the water. Which one will go to the top? Which one will go to the bottom? So what do you think?
One mole.
Okay, correct. H2O.
H2O over 6. No. It's 18 gram.
H2O. Correct. Now, do the math. Gram H2O would cancel with this one. 9 divided by 18 gives us 0.5 mole H2O. Okay. Now, be careful. Look what they are asking. They are asking how many mole of hydrogen. And here, what you get, it is mole, 0.5 mole water. So be careful what you in this type of equation. You need extra step. So what it's gonna be? So here it will be 0.5 mole water
multiplied by 2.
What is the ratio between the atom in the molecule? I have 2 hydrogen. Now, where do you have to put it? This is also important. So where do you have to put the hydrogen? In the top or in the bottom?
On the top.
The top. So it will be 2 mole hydrogen for every 1 mole H2O. Okay?
Okay.
So with this one, do the math. You get 1 mole hydrogen. Okay, or simply this one, you will multiply it by the number of the hydrogen. How many hydrogen you have? 2.
2. Multiply by 2. Okay.
Mole hydrogen. That's how you will deal with this type of a question.
Oh, okay. Moment, Professor. I write down. Yes, this part that I not understand when do the homework.
Okay, yeah. I think we have one example about the sodium in the PowerPoint slides.
Yeah.
When we're talking about the sodium ion, it's already talking about this part also. Try to review it also on the PowerPoint slides.
Yeah, and some of them, they need us to write the action of it, and then we just find out how many, for example, like the water, like H2O is a production already, so they're asking about reaction, about like how many hydrogen and how many oxygen that they go in. So they're asking us to write the homework, one homework that asking to write the action and product.
Okay, yeah, you mean like writing down the chemical equation?
Yeah.
Okay, yeah.
This lesson the same. They asking molecule and atom the same, but seem like they are asking us to write. They give us the production, but they don't give us the reaction.
Give you the product, you mean, and not the reacting?
Yeah, and they're asking one part. I forget it.
Can you tell me which question it is?
It's so slow, my computer.
It's fine, take your time. Because right now I have this the 101. Is it in part 1 or part 2? Because we have 2 parts.
I have a part 1.
Part 1. Let's see what the question you have in part 1. Just one.
Around 6
Okay.
or something around there. Oh no.
It's all okay. Do you see this way right now?
Yeah.
Okay,
Wait.
which one? Should I go down to 6?
Agent. Yes, around the number 6 maybe. I'm not remember, but
Okay. How many gram of NaClR in
no.
24 mole of NaCl? No, I don't think so. This is like it's very clear.
Determine the number of atom something.
Oh, okay. Determine the number of atom of oxygen in 10 gram of CO2. Okay, look at here. Let's do this. Okay, so here 10 gram CO2, and they are asking for number of oxygen atom. We can do it here. It is the same what I did in this example, but they are asking for, but they give you mass. Okay.
Yeah.
First of all, what we have 10 gram CO2. Okay. They're asking how many oxygen of atom. How many oxygen of atom? That's correct.
I don't know.
Okay. Let me just put here. So I think, yeah, the number of the oxygen atom. That's what they are asking. In 10 gram. In 10 gram of CO2. Okay. Now, here they are asking for number, and they give you mass. So which factor you will use?
Give the mass to find mole. It's gonna be 1 mole over mass gram.
Okay, what is the mass of CO2?
CO2 is 12, 16, 44.
44 gram, that's correct, CO2. Cancel this one with this one. Now, right now we have a mole. They are asking for number. So what you have to do? You will use the second factor. When they give you mass and they are asking for number, or the vice versa, they give you a number and asking for a mass, you have to use both factors. Don't forget that, okay? Okay,
so
now,
it's
go ahead.
1 mole of CO2.
Where you have to put it, in the top or the bottom?
The down.
The down, 1 mole CO2. Okay, what about the top?
It's 6.02.
Correct. Times
10 power 23rd CO2.
Okay, that's correct. Do the math right now. Okay, so here we will get, let me see if I can do the math quickly here. Okay, so 10 divided by 44, this times 6.02. Okay, I think I get the number here, 1.36 times 10 to power 23 CO2 molecule. Okay?
Yeah.
Be careful. Here, it is the number of CO2 molecule, and they are asking for how many oxygen atom. So how you will deal with that? You need one extra step. So look at here. Here we have 1.37 times 10 to power 23 CO2 molecule times what? Look at here. How many oxygen atom we have in each one CO2 molecule? How many oxygen atom we have in one CO2 molecule?
We have 2.
2. So we will have 2 oxygen, okay, atom in one CO2 molecule. Yeah, CO2 molecule. Okay, cancel CO2 molecule with the CO2 molecule. This number right now, multiplied by 2, it will be approximately 0.74 times 10 to power 23 oxygen atom. So here, that number, if it's a molecule, you will just multiply it by 2 to find the number of the oxygen atom. You get it?
Yeah, maybe.
Yeah, because how many oxygen in each one molecule of CO2? We have 2, isn't it?
Yeah,
If I have, for example, 10 CO2, how many oxygen? How many oxygen?
10. Oh no, 20.
20. That's correct. 2 times the 10, which means 20. Okay? If I have, for example, 1,000 CO2, how many oxygen will be?
2,000.
2 times the 1,000, and it give you 2,000. That's correct. Now, if I have 1.37 times 10 to power 23 CO2, how many oxygen I have?
It's like 1.7 10 power 23rd multiplied by 2.
Multiplied by 2. So it will be 2 times 1.37 times 10 to power 23, which is what we did here, and we will get the number. That's how we will deal with it. Okay?
Yeah.
Okay. Any other question?
The question that I have, it's not show up. I forget that.
Is it in the homework also?
Yes, it's in the homework, but I seem like not this point, but another point that I need to write the reaction about chemical, because they give us only the maybe number 5.
Number 5, let's check number 5. Okay. How many mole of AgR in 43.6 gram of Ag2O? No.
Thank you.
This is the same what we did here.
Yeah, the same one, this one.
So here, for number 5, you will find the number of mole first, okay? So here, just 1 minute. Okay, so number 5, so you will find the number of mole, okay, number of mole of Ag2O, then you will find the number of mole of Ag. So look at here, for each one Ag2O, we have 2 Ag. So if you have 1 mole Ag2O, you will have 2 mole Ag. So here, what you're gonna find, first of all, you will find the mole of Ag2O. Then that mole of Ag2O, you will multiply it by 2 to find the mole of Ag. because we have 2 Ag in each one Ag2O. The same things what we did with the hydrogen in H2O.
Okay.
Yeah, I think the others there is how many planet vanadium.
Okay. Yeah, I will try myself then.
Okay.
I feel like something comes.
Is it in? Are you sure in part 1 or part 2? You don't remember?
I still in part 1 because I'm not yet done in part 2.
Okay. 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 That's fine.
More is CO2. Now I try to look on the
homework.
work example.
If they ask you, are they asking to write down the chemical reaction?
If we not read, if we not write down the reaction, we cannot find out the how many.
Yeah. Okay. Here.
How many mole of the atom that we have.
Okay. Did they give you the reaction or what they give you?
They give the only product and then they didn't give us the reaction.
Okay. So in that case, you have to find. You can write down the reaction because right now, after starting, you're supposed to be able to write down the chemical reaction by yourself, okay, and find the product and balance the chemical equation. Sometimes combine some equation from chapter 4 and chapter 4.
Yeah.
Chapter 4 and chapter 5. They have some combining equation. So you have to find the reacting or the product, balance the chemical equation, then deal with the these type of calculation. And it's always, you will see like in part 2, when we are talking about the stoichiometry, it's always your responsibility, the student's responsibility of balancing the chemical equation. Check the equation first of all. Sometimes it's balanced, sometimes not balanced. If it's not balanced, you have to balance it, then start doing the calculation. Because if you did the calculation for not balanced equation, it will give you a wrong answer. So always check your equation. Is it balanced?
Yes, maybe around the work example around 8.3 something around there.
Which one? 8?
The work example.
Oh, the work example?
Yeah, in there.
Can you read it what it is?
No. It have answer already, so it's so the beginning.
Okay, so we can go to
another component of acid rain, which also pollen reaction.
So this is the work example. Let's see it here. Let's download it, or we can just show it.
Can we go to the example, the 8.3?
Okay. 8.3. 8.3 or 6.3?
8. 8.3, not 6. 8. Limiting reaction and...
Oh, the limiting reaction. This is in the part 2, okay?
Yeah. Mm-hmm.
Okay. This is for the part 2. Okay. Did you start with the stoichiometry part or not yet?
Not yet.
Okay, so you have to start with the stoichiometry to understand how you will deal with this one. Are you talking about this one? Example 23, mass to mass conversion. So here you have to work with the stoichiometry. Start with the stoichiometry. Okay, this is a little bit different. Here you have a relationship between two chemicals.
Mm-hmm.
Okay, so here one of the component of S-grain is nitric acid, which form the NO2. Okay, assuming that there is more than enough O2 and H2O, how much HNO3 in kilogram form from 1.5 times 10 to power 3 kilogram of NO2. Here we will deal with the stoichiometry, okay, using the mole to mole ratio. Did you start with it or not yet?
I'm not yet do homework, but when I look on the video, I feel confused with that.
Okay, I already posted, I think, one video or two video about the stoichiometry. Did you study it or not? Did you review them or not?
Yes, I review them, but I'm not understand that much. That's why.
Okay, which part you didn't understand it?
It's so hard to say what it is.
Did you understand the mole to mole ratio?
I will read it again. Sometimes I just watch one time. Sometimes it's not completely good for me. I need to read like 2 or 3 times to do that.
Okay, so look at here. So quickly, what we're gonna do? Okay, I will give you an example and try to work with this example. But as I said, you have to go through the stoichiometry because we have a lot of things, okay? And watch this video. But quickly here, I will give you some idea about the stoichiometry. So look, let's say, for example, we have this equation. Okay, another example. Let's say we have H2, 2H2 plus O2 give me 2H2O, okay?
Yeah.
And we have this equation. How many mole of H2O will produce if 2 mole O2 was reacted? Okay, now start with the mole of H2O. How many? Start with the given information. 2 mole O2. 2 mole O2 times what? Here, they asking for a mole of H2O. So here, as a factor, you will use the mole to mole ratio. Mole to mole ratio between which one and which one? Between H2O and O2. H2O and O2. What is the mole to mole ratio? It is the coefficient number from a balanced chemical equation for each chemical. So 2 mole H2O for every 1 mole O2. Now, how you will write it down is very important. Which one will go to the top? Which one will go to the bottom?
It's gonna be 2O gonna go to the bottom.
Okay. Is it 2O or 1 O2? What do we have coefficient number here?
1.
1. So it will be 1 mole O2. Okay, in the top, what do we have for H2O? 2.
2.
So put 2 mole H2O. Cancel mole O2 with mole O2. 2 times 2 give you 4 mole H2O. Okay, now
Yeah.
for the mass, let's say how many a gram. Let's keep the same equation, but we will deal with the mass, with the gram. How many
Okay.
grams of H2O will produce if, let's say here we have 16 gram O2 was reacted. Okay, so here start with the 16 gram O2 times what? Now, be careful here. Here we have mole to mole ratio, not a gram to gram ratio. Okay, what does that mean? If you have a gram, you have to convert it to mole first, and then use the mole to mole ratio. Okay? So you start with the 16 gram O2. What are you going to do with it? We need to reach this point, mole to mole ratio. So that means we need to convert the gram of O2 to mole. How you will convert 16 gram O2 to mole?
Is after like add together like H2O, like H2 plus it's gonna be 18
No,
in gram.
this is O2.
O2. How many H2O? So it's mean 6 O2 32.
32. Where you will put it? In the top or in the bottom?
The bottom.
The bottom. Okay. So here 32 gram O2. And in the top will be the 1 mole O2. Okay?
Okay.
Now, you have the mole of O2 and we need to find H2O. You will use the mole to mole ratio between H2O and O2, which is this one that we use it here. 2 mole H2O for every 1 mole O2. Cancel mole O2 with mole O2. Right now I have mole H2O. But look at here in the question, what they are asking. How many you need to convert the mole of H2O to a gram H2O.
So 1 mole or 2 mole? Oh no, 1 mole.
1 mole. Where you
1
will put
mole H2O. The down.
Down 1 mole H2O. And what about the top?
The top is 18 gram H2O.
A gram H2O. Cancel mole H2O with the mole H2O. Right now, just do the math. 16 grams divided by 32, it will be 0.5 times 2 will be 1 times 18 will be 18 gram H2O. That is the answer. Okay, this is a stoichiometry code. This is very important. Now, go and review the PowerPoint slides and then watch the video. I think I posted 2 videos about the stoichiometry. Okay?
Yeah.
Watch the video and also practice later with the worked example here. But as I said, start with the PowerPoint slides. It's explained very simple way. Okay? And I'm sure you will get all of these. If it's not, just let me know also by tomorrow. Give you more example about this because this is very important. Okay?
Okay.
And always don't start with the homework in the website, in Kim 101 website, until you will finish everything. So review the lecture, watch the video, watch some YouTube videos also I posted there. Watch all these things, then start with the homework. Don't start directly with the homework, okay? Okay, any other question, Con?
No.
Okay, so try to review them, okay? And as I said, tomorrow I will be at the same time here. So in case if you didn't get it, but this is the idea about the stoichiometry, what we will gonna do, okay?
Mhm. Yeah.
And beside what we talk about the mole and the mass or the Avogadro's number, this is the type of the question that we will have it in this chapter.
Mhm.
Okay,
Wait, I write down at the moment.
okay. As I said, I will try to post this video also in a few minutes in the Canvas,
Mhm.
so you can watch it also.
Yeah.
I just have a question. Are you attending also the review session with the tutoring or not? How is working?
Yeah, a lot of people are there, and yeah,
Lot?
it is the same way. Yeah, we just wonder what we not understand, and then we just practice like that the same.
Okay, okay. How many students do you remember? Like each time, like
Last time on Monday, I went. We have 1, 2, 3, 4, 4 of us. Yeah,
oh, just four. Okay, okay. Not a lot. Okay. Anyway.
yeah. Okay, thank you, Professor, for
Okay, well,
today.
stay
Mhm.
safe. Okay, stay safe. Okay.
Yeah, you too.
Thank you. Thank you. Have a good day.
You too.